think we're all set to go then. Topic of today's talk, or my talk today, is going to be distributed authorization with open policy agents. And I'm Anders, and I work as a developer advocate at Styra, just the creators of the OPA project and the main maintainers. I have a pretty long background in software development. When I started out in software development, I lived in Malmö, which is in the south of Sweden. And I used to go to this office space where, and I was just starting out as a developer, and I was like, I didn't know much about anything at all. I was kind of, if you were here in the morning and you saw Orly talk about like imposter syndrome, that was totally me. But there was this one guy there who used to be like a great hacker, and so a fun thing of how things turn out is like that guy is Mark, who's talking here today as well, is in the other track right now. My background is primarily in identity systems, meaning so for the last 7 or 8 years, I've been primarily concerned with like how do you prove who you are in various systems. And when you're in identity, that's kind of a pretty narrow scope. It's kind of convenient to have a narrow scope. But when you work in identity systems, you provide tokens or something that shows or proves that a user identity. So we're basically issuing passports. But just as with passports, they might show who you are, but it's not going to say what countries you can go to. And that's basically authorization. So when you're an identity vendor and somebody asks you, so okay, I got this token from your system. Like, now what can I do with that? We just say that's not our problem. We're an identity vendor. We don't work with like, you got the token. What more can you ask for? So eventually I ended up at another company where they said, right, we got this great identity system that you built, and now we want to do authorization. So I found myself in that very position where I asked, like, how do you do authorization? And I have this identity, now what do I do? How do I use this in various systems to gain access? So it could be a passport, it could be a token, it could be something like this. So what kind of access does that grant me? And that's how I kind of got into the Open Policy Agent project. I think this is actually my 4th year working on OPA, both as a consumer or a developer, and now the last few years for Styra. And if you want to reach out on social channels, it's just my first name followed by my last name, pretty much all of them. So what problem are we trying to solve here? What's the kind of premise of OPA? One of the premises is basically this: how do we do authorization in distributed systems? And the answer is it's pretty complicated. But before we kind of delve into OPA, since I'm an identity nerd, I figure like let's start there. So as we kind of progress from this kind of monolith application and into microservices, the basic building blocks of our applications are obviously they're still the same. We still have the same requirements, the same needs. It's just the kind of the form of communication between these components that differ. So today we're going to zoom in on these 2 components because that's basically what we're interested in here. So if we were, how did we use to solve this in the monolith architecture? Well, a pretty standard approach might look something like this. So the user logs in using some credentials. We set up a session. The application checks, is there a user with this name, these credentials? And once that is determined, we go and check, is the user allowed to access this data? And when that is determined, we get that user the data that they wanted. So a fairly simple model, as with so much else in the monolith architecture. So the application basically handles everything, including authentication and access control. In distributed applications, the first thing we kind of did was to delegate authentication somewhere else. But up until now, we have not really had a good model for how to deal with this for authorization or permissions. So if we were to just take our monolith application and we'd move that right into a microservice architecture, we'd have a pretty naive design or architecture, and it might look something like this. It's basically the same thing we did in the monolith architecture. The user provides a credential, and each service here needs to go and check: are these credentials valid? Is the user allowed to do this operation? And eventually, we'll trail all the way down to the data and return that to the user. So there are obviously a whole bunch of problems with this model. The first one is this. It's basically the use of credentials, passing around credentials around a whole bunch of systems that ideally should have no notion of your user credentials. It's insecure, and it's an information leakage. The next problem is, of course, all the red arrows here, or all the arrows at all, really. We have a whole bunch of calls down to a user service, and when we start to scale out our clusters, we start out to scale out our applications, there's going to be a whole bunch of calls to the user service just to verify identity. And this is going to be slow, and it's going to add a whole bunch of load on this user database over here. So the first thing we can do in order to improve on this, it's what we call delegation. We delegate responsibility for authentication to an external identity system. And rather than passing around credentials between our services, we only pass the credentials to the identity system, and we get something back in exchange, commonly a token, and we pass that token around instead. So now our services no longer need to communicate with the user database here. We efficiently remove that bottleneck. And of course, everyone wants a token, since that's kind of the keys to the Ferrari here. So we have regular users, we have other services, we have devices of all kinds. Everyone wants a token. That's how you get access to our system. So how do we obtain these tokens? That's basically what OAuth2 answers. It defines a set of flows for humans, i.e. interactive flows, and it defines a set of non-interactive flows for our robot or robot friends, i.e. those who can't really log in. OAuth2, however, ironically does not detail what a token should look like. It's all about tokens. It's a whole standard about how to obtain a token, and it says nothing of what is a token. But it's kind of an interesting thing. And another interesting thing is, like, OAuth, despite being labeled an authorization framework, does not offer a whole lot in terms of authorization. You have a very basic, crude kind of concept of scopes, where an application or user can say, I want to access this or that application. But it's not gonna give you more than that. It's not gonna say this user can access this or that endpoint or have this or that data from the database. And another thing OAuth doesn't say anything about is, who is this? What is a user? How do we describe a user? So that's basically what OpenID does. It adds a standard on top of OAuth, detailing what a user is, and things like how do we describe a user? What kind of attributes can we expect from a user? Things like email addresses, phone numbers, identifiers, and so on. So again, OAuth does not tell us what a token is. So what do we do when we get a token? If we don't know what a token is, we're going to have to go and ask somebody. That's basically what we did with the credentials, right? If we have a token and it just says ABC123, I don't know what to do with that. Should that user be allowed or not? Is it even a user? Is it even a real token? I'll basically need to go back to my identity system and ask, is this a real user? And is this token valid? So we're basically back where we started. This is, again, we just kind of pointed our arrows to some other system. So in order to alleviate this, one model of doing this is to start carrying information inside of our tokens. So rather than having to go somewhere and ask about it, we can just look inside of the token and see things like the user ID is this. This is maybe the roles of the user, and some other metadata such as when the token was issued, is it expired, and so on. Once we have that, we can again remove these arrows. There's no longer a need. We can just verify the token using like public keys or whatnot. And in each service, there's no longer a need to go back to the identity system and check. We can just verify them locally, and distributed identity is pretty much solved at this point. One thing to be aware of, though, when you're working with JSON Web Tokens or JOTs, is that they too contain information. So if you're using JOTs, please take note whenever you consider like handing them out outside of your systems. A good identity system would probably issue an OPAC token at somewhere over here, and then have that kind of exchanged for a JSON Web Token inside of your clusters. Because that when your services can just look into your tokens to see who is this, that means, well, anybody else can as well. So you have an information leakage here. So this person, if issued a token, they will know exactly what data you have on them. And well, that might be fair, you say. That's good privacy to know. But another issue here is this user might be a developer, and they might write something like a mobile app. And this is actually a real problem, where they think like, okay, I'm issued a token here, so in my mobile app, I'm going to do something nice. So when the user logs in, I get a token. I'm going to say, welcome back, Anders, because Anders was the name I got in the token. That seems like a reasonable thing to do, right? The problem is, like 2 years later, some new standard is released, or the users of that, or the developers of this identity system, they realize like, oh, we called it user, but the standard actually says username. So let's change that. And they have all their services updated with that change, but of course they had no idea that some user or some developer built a mobile app where they made use of some of your kind of internal data or internal attributes. So you just broke 2 million mobile devices and you had no idea. So please don't issue JOTs outside of your systems. All right, so that was identity. Now, do authorization. And that's basically the evolution of access control. So if we go back to this kind of naive model, we have authorization logic embedded inside of our applications. But in order to know whether a user is allowed to do something or not, they need to go and ask the permission database, because that's where we have that data. And of course, the red arrows here is still a problem. If we need to do this in all services, it's going to be slow. So where should we do it then? Like the traditional model, and one that's been like embarrassingly common, is basically this. It's the gateway model. Say like, oh, doing this everywhere is slow. Let's just do it at one place and we're done. I like to think of this as the mullet model. It's basically just as modern as that one as well. It's business in the front, and once you're past the gateway, it's like an open highway. There's no more checks to be done. So it's very fast. A drawback of the model is you have a single point of failure. The gateway is down, everything goes down. It's insecure, of course, since if you can pass the gateway somehow, you have full access. And if this service wants to talk to this service, there's really no need to go via the gateway. So it basically can do anything unauthorized. And of course, we still have one external dependency. The zero trust model, however, as I think was mentioned in a previous talk too, kind of mandates that you don't trust anybody. You don't make assumptions. You can't make an assumption that there must have been a gateway before me that verified identity, it verified permissions. You can't make any such assumptions. So zero trust means we need to do this in all of our services. But then again, we're back to this model where we started. It's slow. We have a single point of failure in the permission database. It's secure though, because we're doing authorization everywhere. And additionally, we have authorization embedded in all of these services, which might be problematic as well. So we're basically back to where we started. How can we make this better then? Well, the first step is basically, I don't know if you saw, but we kind of flipped the direction of the arrows. So rather than having each service reach out to the database, at the time of an authorization decision, we'd rather say, let's distribute that data out to our applications. So it's available at policy evaluation time or at the authorization decision. Obviously, this might come with a few set of problems of its own, such as if you have a huge set of permissions. But normally, this model works fairly well. You just distribute that beforehand. It's no longer slow since there's no kind of online or direct lookups. There's no single point of failure. If this database goes down for a minute or two, the data is still cached in your services. External dependency, no. Well, another problem here is authorization is still embedded inside of our services. The problem with this is basically this. In a large organization, with multiple teams working on an application, it might look something like this. I used to work in an organization where we had 8 or 9 different programming languages running in our cluster. And that's one of the nice things with microservices, and what it allows is, of course, that you can do this. You can have teams where somebody says, "I want to work in Java." Okay, you'll be in a team where that's what we work with, but some other team might want to write their microservices in Python. But when you work on security, this tends to be a problem. And why is that? Because if you want to do something like authorization and you say, here's how we should do authorization, and you hand that out to these 8 different teams, writing this implementation in 8 different languages, and you're going to end up with 8 different implementations. And they're all going to have their own unique set of bugs. And whenever you want to make a change to authorization, you're going to have to basically reach out to these 8 different teams and ask them to fix something. So coordination between teams and basically progress of changes is going to be very slow. And additionally, all of these languages and frameworks, they're going to have their own very ways of doing logging. So if there's a breach, how do we know where to look? If we need to do an audit, why was user X allowed to do this 3 months ago? Where should I start looking? What are those logs going to look like? Well, they're all going to look different because we have authorization embedded in all of these diverse systems. So enter Open Policy Agent. OPA is an open source general purpose policy engine. So, and the policy engine is basically you provide some policy. You might say an admin can do this or that. And then you have your application query the policy engine for decisions. So it offers a unified toolset and a framework for working with policy across the whole stack. One kind of key concept here is that we want to decouple policy from your application logic. So things like authorization is no longer a concern of your application. And we'll look into that in a bit. But you can think of it the same way as you think of a database decoupling storage. You can think of OPA as decoupling authorization or permissions from your applications. Another thing to note down here is OPA deals with policy decisions. It doesn't enforce decisions. So it might tell you this user should not be allowed. but it's still up to your application to do something with that. Policies are written in a declarative language called Rego. I think we might have some time to look into that. But OPA is not just for authorization. So since it's a general purpose policy engine, you can use it for things like Kubernetes admission control, where you say this or that deployment should be allowed or not allowed based on attributes in the manifest. So you might say that no S3 buckets can be deployed if they are exposed to the public internet. So things like admission control, microservice authorization, infrastructure policies, data source filtering, CI/CD pipeline policies, basically anywhere where you can say, here looks like a good place where we should have some rules. That's where you might want to use OPA. And of course, you can write your own rules in Python, Java, or whatever you're familiar with. But again, we're kind of back to this problem. Once you have an organization with a diverse tech stack and a large tech stack, where do you go to look for these rules? So no talk without this quote, of course. The OPA Policy Agent project is super dope. I finally have a framework that helps me translate written security policies into executable code for every layer of the stack. That's basically what we do. So how does it work then? Put things very simply, it basically works like this. You have a service, and this could be your microservice, or it could be anything else, servicing a request. So we have a pretty broad definition of a service. It could be a Kafka broker, it could be a Linux PAM module, or an API gateway component, or whatnot. Any service servicing a request. When that request comes in, and our job is to determine, should we allow this or not? And rather than doing that inside of our application, we basically decouple that and delegate the responsibility to an external component. In this case, it's OPA. So we send a policy query over to OPA and provided with some input. And that could, of course, be the username, the user roles, or whatever makes sense in that context. And OPA then, based on the policy it has available, and eventually, or optionally, some external data, it makes a policy decision. And that could be either a Boolean one, it could be a true or false, allowed or not, but it could be any valid JSON object. So you can provide maybe a reason, maybe obligations or whatnot, response. OPA runs as a lightweight, self-contained little binary. So ideally, you don't run one big OPA where everybody goes to question, because then we're kind of back to the model we wanted to avoid. You run OPA everywhere, deployed as close to your service as possible. So in the Kubernetes world, that usually entails a sidecar. So we have OPA running inside of the same pod as your application, and you query that on the localhost interface via the REST API. But there are several other ways to integrate OPA as well. As for the policies themselves, they're written in a declarative high-level language called Rego. So just as a real-world policy, a policy in OPA is just a number of rules. And you can test these policies and your rules as you would with any other code. This is basically what policy as code will bring you. It's a well-documented framework, and there is a playground online if you want to try it out. So I think we'll have a very, very brief demo here. I'm just to give you an idea what policy offering might look like. So, okay, we have a package here. We just call it policy. We have a few imports, and a policy is going to look something like this. We might have a rule. I'm just going to call it allow, and I'm just going to say that allow is equal to true, and then say if. And then in the rule body, I'm just going to add all the conditions that need to be true in order for the allow rule to be true. In this case, I might have an input document, which was provided by the application, and in which there might be a user. We're going to ask for the admin role here. So I'm going to say if admin in input user roles. So this would be in the input document, which I had not created. So So if we have an input looking something like this, we say roles, it's going to be an array here. So if our applications provide us something like this, I have a user here, they have the admin role, should we be allowed or not? OPA is going to evaluate that and provide if the condition here is met, we're going to return true. So if we are to evaluate this, we'll just see. There you go. Yeah, we can make it more pretty. But basically, we see that, yeah, OPA did allow that request. And if we are to change the input here to developer, we get nothing back. So OPA denied that. So that's basically running out of time here, but that's basically Rego development and how we can kind of codify our rules and our policies. So you see now we added an OPA icon here into each service. Authorization is no longer a concern of our applications. They just delegate that responsibility. We want this to be as fast as possible. So there's not one big OPA running somewhere. As Abdul alluded to in his talk, there's no daemon set. We don't want that kind of bottleneck. If one of the OPAs goes down, everything else keeps up and operational. So now we can remove bottleneck after bottleneck or weakness after weakness. We no longer have a slow system. We don't have a single point of failure. Things are secure. We have no external dependencies, and we no longer have authorization embedded in our business logic. Now, the last step here, obviously, databases aren't really good at distributing data. So we'd commonly have something like a control plane. That's basically what Styra, my employer, does. And I think that is basically it. Distribution or distributed authorization solved in a zero trust distributed environment. Questions?
All right. I did not expect we would have time for questions. Yes.
Is this different from Zanzibar implementations like Cato or SpiceDB or something like that?
Yeah, that's a great question. So Zanzibar, which is, I think, a Google product originally, right? It's basically a highly specialized permissions database. So it does solve some of the problems of that OPA solves. There's definitely some overlap, but you can't ask. There are many things you can't really query a database for. You can't say, I want to allow this user, given that they are on call. That kind of data is not something that a Zanzibar database would carry. What you rather have there is things like relationships, like this user has access to, based on their role, which could be like a hierarchical thing, should have access to this or that resource. And then you can query, given this resource, should this user have access to that? But there are many things that are outside of or out of scope for Zanzibar. So we've seen quite a few kind of hybrid approaches on this as well. So there's not like, oh, you have to use OPA or Zanzibar. You can use both. So Zanzibar can definitely be that component.
What kind of storage we can use to store policies and as well as the policy data we are feeding to OPA? Is there any like particular storage or?
So basically, OPA works with any data that is structured. So yeah, basically anything JSON or YAML works. And where you store that, that's up to you. But eventually, you're going to distribute that out to your OPAs. So OPA itself does not go out to some external database. That's kind of the point of the distributed architecture. So it's all in memory once you load it in OPA.
Is it same for policies?
Policies are written in this language called Rego, but it's basically just text files, and you package them up in bundles, and you distribute them up to your applications. But how you store them is kind of up to you.
Thank you very much.
Thanks very much.
We have to switch to the
Yeah.
most anticipated part of the. Yeah, thank you. Round of applause.